We are handing the mouse to the AI. This shift replaces static, text-based chatbots with autonomous agents that navigate software and execute multi-step plans. Right now, AI companies are using high test scores to prove their new agents are ready for the workplace. But these benchmarks are often contaminated. They measure how well an AI takes a standardized test, not how well it actually performs your daily operations. DeepMind's levels of AGI matrix reveals a stark gap. While models score as level 3 experts in text generation, they fall to level 1 emerging in autonomous computer use. They might write a flawless essay, yet completely freeze up copying client data between spreadsheets. Conversational intelligence does not guarantee autonomous capability. Relying on chat-based scores to hire a digital worker leads directly to broken workflows, lost data, and hours spent trying to fix the AI's mistakes. Consider the steps required for a general-purpose agent to execute a 50-step process in your accounting software. It must open the application, locate specific drop-down menus, click precise buttons, and verify the final numbers. Around step 20, a mechanical limitation called context decay sets in. The agent's working memory fills up. It begins forgetting the earliest instructions you gave it, losing the plot of the overall task. One missed click leads to opening the wrong tab, which leads to scraping the wrong data. Soon, the errors compound, and you are forced to step in to manually undo a cascade of mistakes. You end up spending 45 minutes supervising and correcting an AI on a task that would have taken you 20 minutes to do yourself. This hands-on, frustrating reality contradicts the viral marketing campaigns that promise flawless, set-and-forget digital workers. Successfully adopting AI agents today requires ignoring the hype and understanding exactly where these systems break. You have to deploy them within their strict architectural limits. The 2026 AI agent market is split between two distinct architectural paths. Enterprise API specialists, like Writer's Action Agent or Microsoft Copilot, operate directly within your software's backend code and APIs. Because they use direct integrations, their reliability is high. If you need an agent to pull data from a mapped CRM and push it to a secure database, they execute the task with strict security compliance. Their limitation is narrowness. If you ask an API specialist to navigate a random vendor's website or legacy software without an API, it hits a brick wall. It cannot function outside its mapped territory. Consumer GUI generalists, like Manus or OpenAI's Operator, navigate strictly by reading the pixels on the screen, mimicking a human user. This approach provides total flexibility. These agents can attempt to use any application, browse any website, or click any visible button. That flexibility creates a trade-off in accuracy. They frequently hallucinate buttons that aren't there, misunderstand complex web layouts, and click the wrong icons. This matrix lays out the choice. You must weigh a highly secure, rigid system that only works in specific apps against a highly flexible system that makes frequent mistakes everywhere else. GUI generalists fail frequently because they lack causal spatial reasoning. These agents read static screenshots of your desktop. They identify text, but fail to understand the physical dynamics of moving digital elements on a screen. This bar chart shows the gap. When tested on spatial prediction accuracy, knowing how objects will interact, humans score 84%. The top-tier models, like GPT-5, reach only 54%. Because of this spatial confusion, an agent cannot predict what happens when a drop-down menu covers a submit button, or a pop-up ad blocks the screen. It resorts to repetitive, nonsensical actions, clicking the wrong areas in an endless loop. Until AI models internalize basic digital physics, general-purpose web agents will require constant human supervision to clear basic interface hurdles. Developers are attempting to fix these failures by using test-time compute. The strategy gives the model more processing time to think, verify its logic, and plan its steps before it takes an action. This scatter plot reveals the trade-off. Extra time boosts logic efficiency by 4x, but for knowledge tasks, error rates spike upward. Overthinking causes hallucinations. Furthermore, scaling test time compute exponentially increases API costs without guaranteeing success. You also face a choice between using a massive monolithic model or a modular framework that stitches several smaller open-source agents together. A monolithic model has a fast, holistic understanding of your goal but easily loses focus. A modular system divides the labor. One tiny agent reads the screen, another plans the approach, and a third executes the click. It is slower, but it maintains accuracy over much longer workflows. Throwing more compute power or complex architecture at an agent doesn't eliminate the fundamental problem. You still have to select the right tasks for the tool. Choosing the right deployment strategy depends on your user profile. The first is the Enterprise Optimizer. Large organizations should restrict agent use to highly structured internal workflows. Use API-driven tools like Writer or Salesforce Agentforce, working inside mapped databases. This path offers a massive reduction in routine workload, though you must accept higher upfront setup costs and strict operating procedures. The second profile is the solopreneur or generalist, who needs broad, flexible assistance across unpredictable projects. If this is your profile, consumer GUI agents like Manus or OpenAI Operator are the best option. They handle broad research, compile lists, and take care of basic digital grunt work across the open web. This decision tree maps the optimal path. Aligning the right agent architecture to your specific business profile is the only way to achieve actual ROI. You must still manage the thought-action gap. Current AI systems lack social cognition. They can parse data, but they cannot read a room or understand human relationship stakes. Treating current 2026 AI agents as fully autonomous, set-and-forget digital workers creates severe operational danger. They will confidently send the wrong email to a critical client or execute a transaction without understanding the context. Treat these agents as highly capable but amnesiac digital interns. They gather research and format spreadsheets, but require your final sign-off before taking any external actions. Deploying AI agents in 2026 allows you to strategically outsource digital friction. The AI manages the mechanical clicks and navigation, while you remain the final decision maker.